So this webinar is lessons from 35 years of pallet rack inspections. And as a subtitle to it, I have fundamental truths from the field and the systems that keep pallet racks in control. So my name is Charles Carbonneau. I'm a chief engineer at Damotech. Um, I will be doing this presentation, and my colleague Damien is going to accumulate some of the questions you may have. At the bottom of your Zoom page, there is uh, um, a button that you can click to ask questions. Some of them he might answer during the presentation, and some of them he might keep, to the end. So I'm going to try to keep this in 45 minutes and then have some time to answer your questions, if any. So why rack safety deserves attention? We do these presentations quite often, well, as often as possible, because there's a lot to teach, and we realize that people have this desire to know more and to be in control. Of course, it's an obvious truth that racking is everywhere in our industry right now. Small damage is rarely small in the sense that, they creep up on you and, you see there's a damaged brace one day, but then another day there's more and more, and maybe there's a problem, maybe there's an operator that's going really too fast that's damaging the rack without even realizing it. And risk is avoidable when it is managed early. So if there's anything you need to remember from this presentation, these 3 points, right, are the crux of it. At the end, we talk about some of the solutions to this. So Damotech is 37 years now. That's why we say built from 35 years of rack safety expertise. We were established in '89. So decades of real-world inspections. We're the largest rack safety provider in North America. We sell engineering products for warehouse protection, rack repair. We have engineering services, rack inspections. We do reverse engineering to figure out load capacity, especially for those people who have multiple different types of racks and different manufacturers through the years in their warehousing. No one rack manufacturer wants to calculate and provide capacity for its competitor. So we go in, we are not a rack manufacturer, and we have the engineering tools to calculate all of these different systems. We also provide rack safety training. As I mentioned, there's a thirst for learning more and more about the domain. So the outline of the presentation is truth from the field. This is where you benefit from the 35 years of being in there. A quick reality check, then some of the lessons that we extract from the field, a few key takeaways, and then Q&A. All that in 45 to 1 hour. So fundamental truths from the field, if we look at it, number one, warehousing has changed. That was really, really common from our own employees, and from the field saying, yes, things are moving along. Rack systems are higher, taller, denser, faster operations and higher velocity is required of you. More frequent reconfigurations, change of seasons, adaptability of the racking systems to what needs to be stored, more interactions with the racking in the sense that you visit these slots often and faster, and therefore they're exposed to more possibility of damage. Increased pressure on the capacity of the racking system. It's got to be fully available all the time because that's how you plan to use it. Now, a truth number two would be like every warehouse is different. This is something we realized through the years. You can't just we can't come to you and say, there's only one solution, only one way to approach it. Each warehouse is different, even within the same company. So companies that have a widespread footing in North America, for example, depends sometimes on the local culture, the different employees, different approaches to safety, different sensibility, also different pressure. So even with a good company culture, overall culture, we can see these differences, right? And we have to be sensible to the fact that uniformity is like almost unattainable on a person-to-person approach. Uh, Truth number three, and we're really going fast. This presentation, by the way, is going to be available as a video, I believe, after we finish. So everything is accelerating. You know, you need to be able to make faster decision making. We have lower tolerance for downtime. If you close an aisle and we can't access it, you know, it becomes critical at one point. If it's closed off, it must not be for that long. And so there's faster repair or replacement expectations, of course. Um, and another really fundamental truth, if you use forklifts, you have rack damage. And even, I would say, even for the ASRS, you know, the automated storage and retrieval systems, we're being asked to inspect those. Sometimes it's more of the insurer that wants to make sure that everything is safe. And so we do these types of inspection as well. Um, but uh, you know, the conclusion of this is that damage is normal. If you have even with robots, we can see some damages. A little box that you tried to store, it twisted somehow for some reason. You try to retrieve it, you push it into the rack, and you damage the ASRS. And of course, if we have humans driving forklifts, 3,000 pounds of forklift, carrying a 2,500-pound pallet, sometimes you don't even feel that you're damaging the rack because you're so heavy. So damage is normal, and unmanaged damage is dangerous. The accumulation of it. Uh, Fundamental truth number five: complacency is expensive. It's easy to say, but you know we've lived it, we've seen it. Planned maintenance is at least predictable, and emergencies put you in trouble. And when you feel you come to work and you're only extinguishing problem after problem and fires left and right, and you know you're not in control. This has a cost because you're not doing the other things you should be doing. So taking a hold of not only damage, but I would say conformity of the racking system, you're in peace. Everything's under control. There's a system and it works. Um, Small issues compound over time, definitely. Truth number six: under pressure, safety culture erodes. Yeah, and everybody, you know, we have to agree that it's kind of the first thing that'll take, you know, that will be pushed aside. And when there's staffing shortages or a large turnover, you have to retrain everyone. You're not going to get the expected results systematically. It's kind of hard to get there. And there's no magic formula for this. Um, Deadlines and speed, of course, put pressure on safety. And of course, I mentioned training gaps. If you have a large turnover, that becomes difficult. Um, and drift happens quietly. So quietly meaning, you know, so you had a safety meeting one week that was planned, but then there's an urgency next week, you know, you push it back to next week, and yeah, there's something else. You know, if 2 weeks go along and you're not looking into it, well, it kind of gets pushed aside, you know, because we have other things to do which are more important. Number seven, good intentions don't replace a program. So as you can see, I'm kind of going towards the practical solutions, which is to have a system in place. Right now, what's happening, well, right now, a lot of people, what's happening, you have damage. Okay, we need to fix it when you at least know about it, because lots of time, if you don't have any system to report it to a manager, they just don't know. And so you damage, you replace or repair. You might have damage again, and you replace, damage and replace, and you just spin around. And at one point you wonder, didn't we fix this like 2 months ago? You know, why is it back? You know, so that's the point. Without structure, the same issues just simply repeat. And ownership must be operational, not just assumed, by the people in place. Because, like I said, you have to extinguish fires left and right. At one point, is anybody taking care of that? And follow-up is really the missing link. Um, Another truth, is inspection data reveals the pattern. So these are data from, we inspect millions of square feet a year. And this is just for last year. We just extracted all of the issues and their priority. And so there's about 2% when we enter a facility, there's about maybe 2% maximum of the issues, the number of issues that we'll get out of there that are of unload priority, right? So this is really, really bad. Usually the clients have already cordoned off these locations, because it's so obvious. But every now and then we see these really bad damages. Nobody said a word, and we cannot believe that the operator did not notice. Like perhaps he was just scared of saying it, and that's also very dangerous. So high priority issues are about 16%, moderate 36, and the bulk of it is really low issue priorities. But by low, it could be, that you're not in a high seismic zone. The nut of the anchors is not tight. Okay. So what's going to happen, right? The rack is not going to fail. There's not much excitement, seismic forces there. So it might be a low priority. In a high seismic zone, it's a high priority suddenly. So what you're seeing here is overall. Now, in the issue component distribution, braces are a big issue, like 35% of what we see. Then beams, then columns, then the rest. Like the rest could be, like I said, the anchors, or there's some out of plumb on the uprights, or there is some missing safety pins, stuff like that. But when you look at this, 35% of braces, 21 beam, and 16 column, that is kind of the representation of the distribution of these elements within a warehouse. You have many braces in an upright that is only 2 columns, and you have more beams than you have columns, right? In an upright. So it really talks to the fact that, yeah, because you have more of them, they're more exposed, perhaps, and that's why you damage them a little bit more. Now, if you have outriggers and you're using double deep systems, beams get a beating very often. There are solutions to fix that, but that, you might have a distribution that is higher on the beams. So reality check, we show these just to um, uh, have these images sit in your mind, where don't want to scare everyone with these images, but just want to say that collapse is rarely a surprise. It's the end of a chain of events of damages or whatnot. Those clients that understand it, they want to break the change very early and see, okay, well, there's a small damage. I want to stop it here so it doesn't never become major failure of the system. So here's an example of a minor impact. Perhaps you've seen those on YouTube, and we share these videos like just about every presentation. Not to scare you, but to say like, come on, he just like lightly tapped the column. What was wrong with this system? Was it overloaded already? Was it already damaged? What? And so we got to look not only at damage, but also at the performance of the system. Was it really well designed for the loads that you put in there? That's a good question. When racks collapse, they fall really vertically. It's not a domino effect. They don't topple each other. They just fall vertically, but then the material falls at the bottom, creating a kind of a cone shape. And that hits the bottom legs of the other uprights where there's the more load right there. And so that's why it's dangerous to have that domino effect. So here's another one, which is probably one of the worst. Just tapped a beam. So again, you ask these questions, how was this thing designed? That was a horribly bad decision to try and squeeze in between the material that was in the middle there. But the consequence is enormous. And clients who've been through these events tell us, what do I need to do for this to never happen again? Never. I never want to have to count my employees on the floor and have to call in. Did he call in sick this morning? We can't find him. And it's horrible. You think of the vibration that, you're in your office and the vibration of the floor, you think it's an earthquake, but then you hear shouting, you come out and you see the incredible damage. You got to get everyone out and you can't go back in to start digging because you're worried that some other systems might fail. So I know this is extreme, doesn't happen that often, but we know how to make these things not happen. This one is a seismic event. You see a guy just running. So he felt the earthquake, just left. And so that's pretty good behavior for the system not to collapse. Bulk stayed okay. Which is interesting, right? So we also know how to design racks that resist earthquakes. So key insights from what we've seen so far is that damage is normal. Unmanaged damage is dangerous. And the real gap is follow-up. So I mentioned damage, damage, damage. We might say unconformity, right, is dangerous. It's not just damage. So the real gap is follow-up is, okay, so we understand damage is real, it happens. We just got to be on top of it. So lessons from the field and common mistakes. Let's dive into some of the experience, of these 35 years being in warehousing. Operating with structural damage, so deformed columns, beams, and braces you see here. Damaged bottom brace, is that super important? It's relative. Depends where you are, depends on the system, how it's been designed, how useful this is. You have to know that these horizontal and diagonal bracing system braces, they provide also for the vertical capacity. Their presence is super important to provide vertical capacity. So oftentimes I have a little ruler that I just compress, a 12-inch ruler, you just compress it, it buckles right away. But you hold it in the middle, and then it's much harder to have it buckle. It's going to buckle as an S shape instead of just a D shape, let's put it that way. And so these elements are really important. Once it's deformed like this, and you see it going high like this, did it pull on the column? Is it kind of indicating to the column if you want to collapse? I just gave you an indication on where to collapse. So deformed columns, beams, and braces. You see here an example of deformed beam. Is it going to have the rack collapse? Nope, nope. But you don't want to receive that pallet, on somebody walking in the aisle or anything like that. This is an example of a deformed column that, I can't believe this. I found this in doing an inspection. It was fully loaded with ice cream. Nobody said anything about it. So examples of back column that is damaged. Just one example of corrosion. This one was kind of protected with a rubber protector. And in time, the humidity got in there and ate away at the column. So, but it was still loaded, So, so at one point, it's going to collapse. So mistake number two, no protection or the wrong protection. So we see these things often. I applaud the effort, but if you hit this, the energy is not going to fully dissipate. The column is going to receive the hit anyway. And here are other examples. Don't tell me that this concrete column was not hit once, twice, 3 times, 10 times, 100 times before it's like this. And think about the cost of repair for this thing. Now we got to go down to the footing of that column to try and repair this thing. It's going to be really, really expensive, hard also. Same for this column that's been punched. right? So these things, if you have forklifts driving along, they got to be protected somehow. And so prevention costs much less than reaction in these cases, of course. Mistake number three, putting loads outside the intended load path. I'll just show side loading. So if you like in this example, these are rugs. They are stacked on top of each other. They're not supposed to be stacked so that they push laterally on the upright, unless the design engineer of the rack said it's okay. Okay, so we're not saying you can't do anything. It's just, there's got to be some reasoning and engineering behind it. In this particular case, you see, I don't know if it's just taped, but they try to put some extensions, so that the rug stays in. Yeah, that's not a good indication. This one here, I'm not sure if it was designed for it because the horizontal brace looks pretty stiff. But it's really rare that we would allow this. You would use a cantilever rack to support such a type of a load. And so that's questionable. I'm not saying it's wrong. It's just, it's usually wrong because I don't hear a lot about engineers designing for that kind of loading. So you got to maintain paperwork that says it's okay. This one on the right is totally wrong. Just by the deformation, it's wrong, wrong, wrong. And even attaching anything of that kind of weight to the upright is wrong. So rack overloading explained. I'll just play this little video. It's a calling of mine putting steel plates. They're 3 by 7 inch, quarter-inch thick. And you see that at one point it just fails. You know? And the way it fails in this example, if I can play it again, yeah, because it's rather fast. So we can kind of feel it as you progress. You see the bottom part, which is the most loaded. At one point, it just leaned on its on the right for us. Um, and this is not a steel model, but you could get something similar. It depends on the height of the first beam elevation. Mistake number four, unapproved modification and field fixes. So yeah, you see the kind of weld here. When we see this, that the paint has been burned, there doesn't seem to be any preparation. No engineer will say this is fine, So we're gonna say, yeah, well, I can't certify this, so we have to replace the upright, or you have to put in a engineered repair kit. Another example, these are two L-shaped braces that are welded together. An engineer would not design this. We have rack repair guidelines that say it's got to be engineered, it's got to be supervised. This is not the case. Attaching a rack to the building, in this case, attaching to a roof truss, what happens if the rack collapses and pulls down on the roof? Well, then it's a much bigger incident, right? If the roof comes down with the rack. So, of course, never recommended. Attaching the rack to anything, if it's not been designed for this, or the building has not been designed for this, we shouldn't do it. Inadequate deck, that's a minor issue, but it's like questionable. Why, what's happening? Why? So in this case, you see there's a gap between the two wire meshes, and there's uh, wood plank. I lost a word here. So just on top of it, is it fixed? Can it slide off? How does it work? These are the kind of issues that we see and we try to prevent. Some more modifications and field fixes. If the clearance between the pallets and that I don't know if you see it, there's a white tube right here. It's very questionable when you raise that pallet here, which looks like a pallet on top of a pallet. Do you not hit this thing? What's the clearance with it? Maybe I would just condemn that portion of the rack. Proximity or clearance to the building also, because during a seismic event, you would just hit the building. What's on the other side? What's the consequence? Those are the things that we have to check. It's not a damage per se, but it is an issue. Same issue over here. Sprinklers attached to the rack. So if the sprinkler designer did not take into consideration that these racks move a lot during a seismic event. Down aisle, especially, there's a lot of movement. If that movement breaks the connection and then water doesn't get to the other locations where you need it during a fire, well, we're all screwed. Mistake number 5, reconfiguring without engineering approval. So in this particular case, in this image here, I would question this connector to the left, right? Because it's got teeth, and these teeth are not entering into these slots over here. So that's kind of a strange, operational way. So I think they put some bolts through, but it doesn't seem to be the right connector. Mind you, you have to think it's not only gravity loads, it's also the downwell behavior of that rack system that we have to take into account. So similar parts doesn't mean you have exactly the same capacity. And we say that because if you replace an upright which had a gauge of 13 and you replace with a gauge of 14. So a gauge of 13 is 0.09 inch thick and 14 gauge is 0.074-ish. Well, it's not the same capacity anymore. And it looks exactly the same. It's not just the same thickness. So that's why we have a rack repair guideline, which is on rack repair or replacement, because the same requirements are for replacement. You just got to make sure it's the right upright, that you replace. And by the way, when we do our inspections, we go to that level of detail of checking, the gauge of these columns, and we find all kinds of differences. That's might be one slide I should add in the things that we find out there. So load capacity can drop significantly. We have to verify, of course, before loading. We should make sure if you make a change, for example, here, we wanted to move the beams 12-inch or 18-inch higher, and that comes with 33% less capacity when we do the calcs, which is significant, right? If you had kept your 4,500-pound pallet, it would have collapsed, perhaps. I say perhaps because yes, we do have safety factors, but they're not there to protect you against these kind of mistakes. They are there to protect us against the fact that material might not be perfect. When you roll these shapes, either hot rolled or cold formed, right? They're not perfect, So as soon as you load them, they have a tendency to kind of move laterally, and side sway slightly. We take these things into account. We have factors that limit the capacity for those reasons, right? It's not a reason that I don't want to do the calcs, right? It's got to be done. So unapproved rack configuration explained. We say explained because the image is worth 1,000 words. What we do here is we load it up completely. You saw that. Now we remove one beam level and we try, I say try, to reload it. But my colleagues got to hold it because it wants to go so bad. Oh, we could feel it, just after putting one level. So doubling that non-supported length of below the first beam, which is now the second beam elevation, that actually diminished the capacity of the rack by a factor of 4, which is it punishes you badly. So other hidden warning signs people might miss, so missed or pulled anchors. Yeah, so like this, so how come the column is not touching the ground? Was there an impact, previously? Is it loaded or not? Out of plumb uprights, that's also an issue that we look into. It's not normal to go beyond tolerance. So tolerance is half an inch over 10 feet once loaded. So if you install it brand new, it should be a 1/4 inch over 10 feet. And that's not really easy to measure. Can't really see it with a bubble gauge like this. You need to use a laser. Out of plumb or out of straight, it could be because the rack system is overloaded and now it's going into kind of an S shape, or the delivery of the upright, it's been damaged during shipping. Right here, we're putting a laser line onto a column, and you can see at the very bottom, the laser is to the left of that half-inch diameter hole, and at about 5 feet, it's already to the right. So you're right there at twice the tolerance of the design standard. And that applies for US and Canada. It's the same across North America. Missing braces. So in this particular case, inspection is really hard for missing parts, because it looks totally normal, but right here, there should be a horizontal brace, right? What's the importance of that brace? You got kind of have to go back to the designer to know. But I don't know of any designer that would say, "Oh yeah, yeah, no, don't worry, you don't need the brace that I designed." No, he's going to say, "No, that's not my upright anymore." I certified the capacity for an upright that had a horizontal here. It's not there. You don't have the capacity, and it's not my upright anymore. So I just zoomed in over here to show you. It used to be here. There used to be welds right here. Um, so it's definitely not normal. Missing braces or safety pins, we see that a lot. And it's an easy fix, just go in, fix those as fast as possible. This is an automated safety pin. It's spring loaded, kind of, and it was broken on this side to the left. And consequence, that is that a beam can partially detach, like in this case, but it for sure, this is really dangerous, because you're not held with all of the teeth that should be into the column. Damaged connectors or shims, these are all other indications, and when we do a full in-depth inspection, we look for those as well. And so we get to best practices. I think we're pretty good on time. Yeah. So what does OSHA say about what needs to be done, right? It's not just OSHA, it's also workplace safety. And I think across North America, I know that across North America, it's uniform. And the wording is employers must maintain a safe working environment. Just rather boring, not very detailed, but it's got a lot of meaning to it. And we got to be careful about what it really means. So we know that for racking, this translates into, improper racking use, selection, installation, or maintenance increases the risk of worker injury. So it's like, we have all these racks. They're kind of a commodity because what we operate is the warehouse, the stuff that we put in and that we need to ship out. That's the focus. But these things, they're kind of a commodity and, they operate, they stand upright and whatnot. And so what we've heard from those who went through traumatic experiences is that we kind of knew, kind of had reports from some employees saying, "Hey, is this right? I don't, and they're working the floor, they see it, they feel it. But the manager higher up above, they didn't see or feel it that much. And when they realize, oh, it's my responsibility, ultimately, then they kind of need to get involved. And how do you do that? So we'll just go through the owner responsibilities according to the design standards and best recommendations in the industry. So you must perform inspections. You're kind of responsible for knowing what's in there. You have to maintain documentation. That would be LARCs, load application and rack configuration drawings. This engineering stamp drawings or somewhat of a report on the calculation and the capacity of your racks, right? And the way that they are today, that has to be maintained. And then implement procedures to report and act on all of the issues that are raised. And I say issues, it's not just damage, but usually once you have like a real professional come in and they look at the whole facility, they provide you with an engineering report saying, okay, here are all the issues. This rack is really too close to the building column. It should be off by 6 inches or 12 or whatever. Now it doesn't mean there's a level of urgency to this. It's an issue along all of the other issues. And so you plan to to act on the unloads and high priority issues first, and since rack systems are living entities, right? You live through these entities and they have accumulated damages. You might not reach the end of your moderate or moderate issues for a while because there's higher priorities that come into play. But as long as you're in control, everybody's happy. So rack standards exist for a reason. So in the US, the IBC, the International Building Code, refers to ANSI MH 16.1, which is the design, testing, and utilization of industrial steel storage racks. So you have racks, here's a standard on how to design them, right? In Canada, the National Building Code refers to CSA S345, which is design and construction of steel storage racks. Same thing, right? Different path of being created. So this one, latest version 2023, and so is MH 16.1. So the true cost of rack safety issues is to, think about the people, of course. We don't want anyone to get hurt. That's, obvious. But, you know, operations might be affected, and not necessarily talking about collapse here. Operations are affected if I need to cordon off certain rack slots, pallet slots. Inventory incapacity is going to be affected, of course. And, if I'm not compliant, somebody from OSHA might come in and say, well, this doesn't look good to me. So you get someone in and you fix everything that needs to be fixed. They're not going to be able to inspect the whole thing for sure. But they are made aware of these more and more. So they had recently a program where they wanted to focus because the warehousing industry has more incidents apparently than other industries. And that might be related more to forklift use, but rack damage is part of the whole deal. So success in practice. So what we've seen that works, so how warehouses move from risk to control. So common rack safety mistakes appear across industries. We've established that. What changes is how they are addressed. So we're getting to the solutions now. So how a food distributor gained control. This is a client of ours, one of which that says never again. And so that we proceeded with baseline inspections of all our facilities. So these are engineers. And as we were doing it, they were kind of gaining on better understanding, seeing the reports and what we're reporting. They're kind of learning, oh, that's important. Okay, that's important. And at one point, they get the hang of it and they can go ahead of us, to try and fix these things all across their warehouses. Load capacity was not displayed on the racks. That's a problem. It has to be if you want to be conformed to the design standards and to prove that you're in control of your capacities. You have to establish clear risk-based priorities, and this is what we do during our engineering services. Trackable follow-up rhythm, so you get into the habit of repairing and tracking and whatnot. So another success in practice, speed wins in big box retail. So fast risk-based prioritization, that helps a lot. Then you get into the habit of doing fast repair executions. So some of our clients, they had like it's got to be fixed within a month, whatever. And then, COVID happened and there was all kinds of difficulties getting the materials. But after COVID, they kind of pushed the envelope to say, no, it's got to be fixed. Let's gear up to make it execution really, really quick. And in doing that, of course, the risk is reduced week by week. So at one point, you're just running the system, but there's no big surprises anymore, right? Oh, there's a big damage. I hit it. Wrong pedal on the forklift. I backed into it like really hard. We were lucky that nothing failed. We unloaded. We know what to do, right? It's not a big deal anymore. We're used to it. Success in practice. So prevention reduces repeat damage and manufacturing. That was another client. And of course, in manufacturing, you need the parts. It's got to be really fast because they're producers. So they had repeated impact zones identified. They were repaired. And right now you're looking at a Damo Pro kit, guaranteed for life against impact, incredibly strong, you know. And even the manufacturers look at this and say, wow, this is like over designed. But yeah, it is because that's the end of the repair cycle for this location. It's that at an end of aisle, they had damaged it once, twice, maybe thrice. And then, we came in with this thing and that's it. Done. Um, so what does a complete rack safety program require? Um, I'm going to go through this rather fast. So inspection, insight, maintenance, prevention, internal knowledge, and external expertise that you can use for it. We baked all of these elements into what we call the rack safety flywheel. And it's a flywheel because you can come into different locations in this flywheel. But as you put some weight onto these um, elements, it starts to roll. This is what I've been trying to hint that this is what we found that works. It's a system that is kind of clearly identified, but every time you put the shoulder to the wheel, it gains momentum. And at one point, it just becomes habit. Um, so a safety program needs also a memory. If issues are tracked, if they are not tracked, they can repeat, and turnover resets progress and undocumented programs. So this is all leading to the fact that you need a system, and site history matters. So of course, we have developed such a tool because of what we uncovered during these 35 years. Findings become actions automatically. Issues are tracked from open to close. History is kept by bay and location, so you can go back and see what happened the last time and whatnot. So, what do the best warehouses do differently? They build a program that closes that loop. Um, they do the inspections, then you have findings, then you solve them, you get closure on these issues, and then you think about prevention. Is this something that we can prevent? What's the cost of protecting perhaps these assets? Do we need to do it all over or just localized? You get more time to think about these things because most of the others are like, you have a process in place that fixes it. So if I was to explain the flywheel, there's no particular order, but if we go from something that feels logical, you inspect stuff, you get insight so you can prioritize what you need to do. You actually do it and close these issues. And then you can think about prevention to limit these issues that could come again and again. You train your personnel. Perhaps you use a third-party expertise to build some more momentum. And then you get to the core of what you're trying to accomplish, which is employee well-being. I need compliance to design standards, and I want operational efficiency. That is rack safety to us. Um, and so, yeah, this is going to be made available, but you can download a lot of information. We have a toolkit, and we come to one of the few last slides in very good time. So some key takeaways, and it's only a few slides on this, and it tells really the truths that we've seen out there. So we conclude that damage is inevitable, but collapse is really optional. It becomes a choice at one point. Safety scales with systems, not only with good intentions or individual heroics. These are insufficient. When you have employee turnover, or you had one great guy, he's like wonderful, knows everything, but transferring all of this, if it's not in the system, we've seen that it tends to kind of dissipate. Um, we initially talked about having a culture of safety, big words. Very nice, a culture of safety. Yeah, but yeah, try to implement culture of safety. It takes years. Yeah, it's difficult. One example I was saying, people, if you had to go to work and you're kind of late, did you fully respect the speed limit? You know, culture of safety says, yes, I did. I did not go 1 mile above the limit, right? And so on a personal level, we all have these situations in our head where we're saying, well, I chose this because, and I've got a reason why I didn't do it, right? Or I did it right, or I didn't wrong. We always reason in our heads why we didn't do it. When it's a program, when there's a calendar, there's things to do, and we have to do it, and we maintain not pressure to do it, but we are definitely comes from high above in the industry, in the business, sorry, um, that we want to do it, and there's reports to be made. Well, then it gets done. One last point here. So what gets tracked gets fixed, and what doesn't just repeats, which is a fundamental truth, not only for rack safety, of course. So how can we help? This is more maybe a sales pitchy, but yeah, maybe you'll find some very interesting things in there because we're the only ones out there providing the whole range of products and services. We only focus on rack safety. There's nothing else. We're not in buildings. We don't provide engineering services for anything else than rack system. So we have integrated, and we present ourselves. We want to be a rack safety partner. Your focus is execution of the warehouse. Our focus is this portion of helping you be on top of rack safety. That commodity that you never have enough time to look into, we take that pain away. So we have integrated solutions. We're the largest provider in North America of products and services in rack safety. Engineering expertise is compliance inspections, load capacity calculation, where we start from scratch. We go in, we measure everything. You might think it costs a lot, but it's really impressive. We have developed incredible tools to go fast and be able to do it with a level of details that I've never seen any engineering firm able to do. I'm not kidding. I've never seen an engineering firm take the time and look at it as closely as what we have. And of course, we develop our own tools to be able to do that and training and whatnot, so that when you trust a Damotech with your inspections, it comes also with some uniformity of inspection across different facilities. And we provide rack safety training. We're coming out very soon with an online rack safety training that talks about how to inspect things, and we go into a little bit more information there. Along the safety products, we have a slew of rack repair solution. What you're seeing on screen here is the Demo Pro. We have rack protection kits. So protection in terms of building column protections, rack column protections, all kinds of different products there. And we provide lifetime warranty against impact on that Pro line. The Damotech platform is where we put out all of our reports. So it comes in with that layout view of your whole warehouse with all the dots of all the issues that we've seen, color coding of the load capacities also. And we have side views showing the capacities as well. So when you're looking at a rack system, we have views of each rack system, like if you were standing right in front of it. And of course, we have this inspection software that you can use across into the platform. So additional tools, if you want, you can capture these QR codes. And the video of the presentation will be available on the web. And there we go. We're at the Q&A session. 10 minutes left in the presentation.
Great. Thank you so much, Charles. I have some questions for you. I'll start off with the first one. In your experience, what risk is most commonly underestimated by facilities?
Yeah, so thank you, Damien. So we logged in 30 minutes before the start of the presentation, and I was saying, right off the top of my head, I think that load capacity has always been a rather big issue. And clients complain about it, saying, "Well, I don't know. Where's the paperwork? I don't know. We bought this facility or we bought this, and we moved into this place 5 years ago. I don't know." And so the platform, the Damotech platform, is one good way of putting the data onto that, even the larks. That was an idea, that just to put everything there, it's in one place, and your issues, everything is just in one place. You can't lose it, right? It's not just paperwork anymore. It's right there on the cloud. You can invite your boss to see the progression of your repairs. You can see all of the issues that are being fixed as you go along. So yeah, knowing your load capacity to me is a biggie. It used to be that well, it is still like that. When we do our inspections and we see that there's no displayed load capacity on the racks, it's just a general remark. But most of the time we push our sale we push to do both services. That is, when we do a baseline inspection, it should also come with load capacity certification. Uh, and we do take responsibility. So we're the engineer of record when we sign these load capacities. So it's serious business because you have to know a lot about other types of rack systems, partial rigidity of the connectors, same for the base plate. And we do all these analysis. So we've become quite an engineering, um, well, we have more than 50 engineers on staff, most of them going out there in the field and gathering information, and a few engineers, of course, uh, in-house that do quality assurance. So every report is always seen by the engineer that was on site that generated the report and the calcs, and there's a reviewing engineer on top of it. That was a lengthy answer for a small
Yeah.
question, but
Well, great. Thank you, Charles. I want to include someone from the audience. Zeke, he asked a question. I found it rather interesting. Very interesting questions. So his question is basically, when anchoring is prohibited by a lease, what engineered options, if any, exist to address rack stability? And where is the hard stop?
anchoring is prohibited by a lease. I've never heard of that. That's interesting. So, well, hopefully the racks are anchored, because if you're operating the racks with a forklift, it has to be anchored, you know, unless it's a very specific design that I've never heard of. But let's say for regular racks, they have to be anchored if operated by a forklift. If it's all hand picking, well, that's another story. Um, you know,
Yeah. And so when someone does spot damage, let's say during a shift, what are the first two steps you want them to be taking?
yeah. So there's different approaches. So depending if you don't have any program in place or nothing. So quick solutions for that we've seen through the years. Someone had bought little pucks of reflecting material, and they would just stick them magnetically on the forklifts, and they were saying, "I don't want to know who did it. I just want to know, if you see it, report it." And I don't, yeah, you're not going to stop driving for, writing it on paper and whatnot. And I have to accumulate everything. Just put a magnetic marker on the front column so that at the end of the day, somebody goes with a flashlight, just flashes at about 24-inch from the ground. If one of those reflects, he goes in and takes the necessary information. It could be just a simple picture with a location, so you take a picture of the location, take a picture of the damage, and then you call in either an expert to judge, does this need to be unloaded partially or not? When I say expert, it might be your representative, your rack representative, I don't know. If it's you personally, well, then you have to kind of judge right there on the spot, do we need to unload immediately or not? Trained forklift operators have that power that they can say, "Oh my God, that's a biggie," I'm worried. They get a kind of a feeling for it. So then they will have to report it as soon as possible.
Makes sense. And the next one for you. So how do you prioritize damage when there's a lot of it in the facility?
Mm. So it's really a one by one thing. So the way we approach it, if on an upright location, the front column has been hit, um, just the front. I can see a dent in the front. I can see the first horizontal bent like 1 inch, and I can see the first diagonal bent 3/4 of an inch sideways, right? And the back column is damaged, but at the second beam level, right? So we just accumulate all of these and we say, well, the first front dent that I see is a moderate. But the brace that deformed, the horizontal brace deformed 1 inch, that is a high priority for sure, right? And the diagonal brace as well. So that's two highs, one moderate, and perhaps the back column at the second beam level, maybe that's also a moderate, right? And so the way we look at it, we see, well, for that position, how bad is it, right? Two highs plus two moderates, it's certainly going to trigger a repair for that. But we look at it damage per damage, and then we just accumulate them all. By the way, I get this question very often. So, um, can anyone determine by how much I lost capacity? I'm not putting the full load. It's a racking system that's made to support 2,500 pound pallet. I'm just putting 1,200. So, it could be damaged like 50% and I'd be fine. Well, there's no engineering or even manufacturer that thinks like that. It's always, yeah, well, yeah, it's kind of risky because now that you think that you lost 50%, everybody's that's looking at it thinks, oh my God, it's damaged pretty bad, So yes, I did lose some capacity. And so what's the difference between today, where we establish it's 50% loss, and tomorrow, where you dent it again, and now it's 55, 59? We don't know. We would have to have like very precise pictures so you can compare. Is it like it was yesterday or not? I don't know. I'm lost. So, yeah, we can't do this. You have damage, you need to repair or replace. That's the only path that we have forward.
Got it.
Did
And the
I?
last the last question I had for you is if the audience remembers only one thing from Damotech's 37 years of experience, should it be?
Oh, get into the program. That's it. Um, Good intentions, like we mentioned, doesn't 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 stand the test of time. Um, and even establishing programs has its limits, right? It's got to be from the top level management that says, okay, I want to invest in this because I don't want to have to care about it anymore. You know, it could be like this. We are warehouse operators. That's our main focus. And yes, of course, maintenance of racks is part of the experience, but it's not your core focus, right? And so what we're saying, when you install a program that has a tendency to kind of run on its own, well, you can go back to focusing because this thing runs on the side and it's kind of responsible for looking at its own issues and saying, hey, we gotta stop these issues from coming back. What do we do? What kind of budget are we looking into, right? And so you get a hang of it and you're just operating, operating, operating. That's what we see on the manufacturing side, on the people who run distribution centers as well, right? So rack damages and rack safety is just a pain, to put it bluntly. My main focus is I need to operate this thing. And so, yeah. getting into a program, getting a partner. We insisted on different presentations in the past on getting a partner, and it's because we see so much, not disinformation, but lack of knowledge of rack safety. We come, our approach takes into account the fact that you might have seismic forces, horizontal forces in the system that you need to take care of as well. It's not just the gravity loads, right? It's the whole entirety of the system.
Great. Thank you very much, Charles. That's it for me on the question side.
Well, thank you. I see there's still a lot of participants with us. We've went over a minute. I want to thank you for being present and being aware of rack safety, and I wish you well